Hello, this is Geometry, topic 5-3, over area and volume of cylinders and cones. So, let's go ahead and just review our formulas real quick. We're looking at our formula chart. For the surface area of a cylinder, it's 2 pi rh if we want the lateral. If we want the total, it's 2 pi rh plus 2 pi r squared, which is the lateral plus the base. For a cone, our lateral is pi rl, and for total, it's pi rl plus pi r squared, the lateral plus one base, whereas the cylinder has two. Now, volume of our cylinder is area of the base times the height, which will be pi r squared h, and the volume of our cone would be 1/3 of area of the base height, which is 1/3 pi r squared h. So, going to be referring back to this as we work through our problems here. First, it says find the total area of a cylinder with a radius of 6 and a height of 8. Well, our total area equals, this is a cylinder, so we're looking at 2 pi rh plus 2 pi r squared. So that means 2 pi times 6 times 8 plus 2 times pi times 6 squared. Well, 2 times 6 times 8 gives us 96 pi, plus 2 times 6 squared gives us 72 pi. We add 96 and 72 and we get 168 pi. Let's go ahead and look at example number 2. Here it says the volume of a cylinder is 81 pi, the radius is 3, find the height. So we look at our formula. It says that volume equals area of the base times the height, which we know is pi r squared h. So 81 pi equals pi times 3 squared times h. So 81 pi equals 9 pi h. Divide both sides by 9 pi and we get that 9 equals h. Now, in example number 3, we want to know what the volume would be if the dimensions were 3 times the original length. And here we're talking about volume. Well, volume is three-dimensional. Okay. Want to make sure that you look at this and see a D, not a 0, so we'll just do a lowercase d. Volume is 3D. So that means that we need to multiply by the change 3 times. So our original volume was 81. So we're looking at 81 pi. When we multiply by 3, by this 3 to the third power. So 81 times 3 to the third power is 2,187 pi. So multiplying all the dimensions in volume certainly makes a very big change. All right, let's go ahead and look at example number 4. We have total area of a cylinder, so I'm going to go ahead and write that down. The total area of a cylinder would be 2 pi rh plus 2 pi r squared. Now they tell us that it's 144 pi, so 144 pi equals 2 times pi times a radius of 6 times h plus 2 times pi times the radius of 6 squared. So that means that 144 pi equals, this would be 12 pi h plus 36 times 2 makes 72 pi. Well, we're going to go ahead and subtract 72 pi from both sides. So 144 minus 72 gives us a 72 pi equals 12 pi h. We divide both sides by 12 pi, and we get that h equals 6. Moving on to example number 5. Well, example number 5 says, what's the total area if the dimensions were reduced to 3/4? So they gave us a total area of 144 pi. Now area is two-dimensional. So that means I'm going to multiply by my change squared. So 144 times 3/4 squared. And just so you can see how it's put in the calculator, 144 times 3/4 squared, the 3/4 is in parentheses to make sure I square the whole thing, and we get 81. So this equals 81 pi. So area does not change quite as much as volume, because area is squared and volume is cubed. Take a look at example number 6. This time we have a cone with a radius of 5 and a volume of 100 pi. We want to find the total area. So I'm going to go ahead and draw a picture of my cone over here. Let's say the radius was 5 and the volume is 100 pi. Well, volume equals 1/3 pi r squared h. Because it's a cone, so it's 1/3 area of the base times the height. So 100 equals 1/3 times pi times 5 squared h. So 100 equals 1/3 times 25 pi h. Well, I do not like fractions, and 1/3 does not multiply to 25 and give me something pretty. So I'm going to go ahead and just multiply both sides by 3 to get rid of it. So now I have that 300 equals 25 pi h divided by 25 pi, and I get that h equals 12. So that means that my height is 12. Now to find total area of a cone, we're talking pi RL plus pi r squared, which is all fine except for I do not know what my L is. So I have a right triangle that is 5 by 12, so good old Pythagorean theorem, 5 squared plus 12 squared equals L squared, and 5 squared plus 12 squared is 169. And I happen to remember the square root of 169 is 13. So now, my surface area equals pi times my radius of 5 times my slant height of 13 plus pi times my radius of 5 squared. So 5 times 13 is 65. So surface area equals 65 pi plus 25 pi. And 65 plus 25 equals 90 pi. So my total surface area is 90 pi. Now let's take a look at example number 7. We're talking about cone A and cone B. And we're worried about volume and lateral area. So let's go ahead and talk about cone A. Well, volume equals pi 1/3 pi r squared h. So this will be 1/3 pi times 9 squared h. So 9 squared, we have a height of 9. No, height of 9. Sorry. Radius of 9, height of 12. So 1/3 times 9 squared times 12 equals 324. So for cone A, that's 324 pi. For cone B, that's going to be 1/3 times pi times 12 squared times 9. So 1/3 times 12 squared times 9 is 432 pi. So cone B has the greater volume. Now to find our lateral area, we need to know our slant height. So if my radius is 9 and my height is 12, 9 squared plus 12 squared equals 225. And the square root of 225 is 15. So L equals 15. And if I go ahead and do it the other way, well, that's 12 and that's 9, I'm also going to get 15. So my slant height is 15 for both. So now, the formula for this is pi r L. So we're talking about pi for cone A, pi times my radius of 9 times my slant height of 15. 9 times 15 equals 135 pi. And for cone B, it's pi times 12 times 15. And 12 times 15 is 180 pi. So again, with cone B. Basically what this says is the radius has much more effect on a cone than the height. Because cone B had the larger radius and the smaller height, which made it larger overall. Even though they're the same numbers, the radius being bigger made cone B bigger. So, remember your formulas. Remember to plug them in. Good luck on your assignment. Have a good day.